Hello again. Let's do an example where we have two individuals, Alex and Clara. We have production functions for them, and so we can draw the PPF for these two individuals. All right. Looking at Alex's production function, so we have two goods here, apples and oranges. And so just looking at this table here, can I draw a PPF for Alex? Yes, I can. I put oranges on the y-axis and apples on the x-axis. Great. And then I can draw the PPF by just looking at the ends of the table here. So for oranges, the biggest number that Alex can produce is 300, right? So I put 300 here. I'm not done though. I need the biggest number of apples that Alex can produce, and that's 100. So I put that here. Now I'm just trying to make this look like it's drawn to scale, although it's not. And I'm going to use my ruler here so I don't make mistakes to join these 2 points. That is Alex's PPF. Very simply. Can you figure out how to draw Clara's PPF just following what I just did? Pause the video and try it. Okay. Hopefully you paused the video and you're now coming back to try it. Say you didn't, that's okay. You can just look at what I am doing here. Alright, so we have apples on this x-axis and we have oranges on this y-axis. Now, the maximum number of oranges that Clara can produce is 200. The maximum number of apples that Clara can produce is also 200. So hey, this one is super easy, right? You can just join these two and you are almost done. You have quite a bit of work to do on this one here. Let me send that ruler away. And so this here is Clara's. Looks like I took a pencil, but that's all right. Clara's PPF. That's Clara's PPF. Great. So what did we just do? We took 2 tables, one for Alex, one for Clara. In each table, we have 2 goods. We plotted one of the goods on the y-axis, oranges, the other good on the x-axis, apples. Then we looked at the table and took each individual's maximum number of each good that they can produce and used that as our end point, connected the 2 points, and we have our PPF. Great. Is there more we can do with this? Yeah, there is more we can do with this. One thing I want you to stare at here for a while is if we just consider oranges and Alex puts all of his factors of production towards the production of oranges, he can produce 300 oranges in the same time Clara is producing 200 oranges. So it looks like Alex on the orange point of things is doing better than Clara. Now when we come to apples, Clara is doing better because she in the same number of time or in the same amount of time she can make 2 or produce 200 apples, while Alex is doing only 100. If they both put all of their factors of production towards the production of apples. So here we say that Alex has absolute advantage in producing oranges, and Clara has absolute advantage in producing apples. We can do more. We can calculate opportunity cost of producing apples for Alex and for Clara. Why? Well, Clara and Alex may want to trade if they can find out who can do the better job at producing each good. What I mean is, who gives up less to produce apples or oranges? When we figure that out, we can have the person who gives up less the opportunity to just specialize in that good. So let's calculate the opportunity cost here for the opportunity cost of producing apples. The formula that I'm going to use is oranges lost over apples gained. And what I'm going to do here, I'm going to do the calculation for Clara first, since I can see hers right up here. So let's do the calculation for Clara in black. We are going to just use the endpoints to calculate the opportunity cost. Why? Well, this is a linear PPF. I have multiple videos so far on PPFs and how to draw them, so please check that out on your own time. Okay, we are going to use the endpoints to calculate the opportunity cost here. So for Clara, oranges lost, so the orange number is 200. So oranges lost 200 over apples gained 200. You do the math, that will be, let me write this in full. 200 oranges lost, apples gained in the denominator, and so we have 1 orange lost per apple gained. For Alex, let's scroll up. We have 300 oranges and 100 apples. So 300 oranges divided oranges lost divided by 100 apples gained. Okay, we do the math. We have 3 oranges lost per apple gained. Great. There are more questions that we can answer using just these two numbers. Considering the two numbers that we have calculated, the two opportunity costs that we have calculated, one for Alex and the other one for Clara, who has comparative advantage in producing apples? What does comparative advantage means? Well, if you've been to class, I hope you're coming, it means who gives up less oranges to produce an apple? It's Clara, right? Clara gives up less oranges to produce an apple. And so Clara has comparative advantage in producing apples here. So Clara is the answer. And why? Well, she has the lower opportunity cost. She has the lower opportunity cost. That's the answer. Who should specialize in producing apples? Clara should. Clara should specialize in producing apples. And what is the range of apple prices? The range of apple prices here will be just these two numbers we have calculated. 1, 2, 3 oranges. That is the range of apple prices. Now, how do we explain this? Well, let's start from this perspective. Why is 1 the lower bound on this range of apple prices? Okay, to answer that, we need to know who is going to be selling, who is going to be specializing in apples and selling apples. It's Clara, right? If Clara is specializing and will be selling the apples, then Clara would like to sell her apples for more than it costs her to produce it. Right now, it costs her 1 orange to produce this apple. So she would like to sell her apples for 1 orange or more. Do you see what is happening here? So that's the lower bound. But what about the upper bound? Now, Clara would like to sell her apples for 1 orange or more. Can Clara sell her apples for 10 oranges? No. Why not? Well, because Alex, who is purchasing these apples from Clara, would like to purchase it at 3 oranges or less. Do you see? Why less? Well, if Clara insists to sell her apples for 10 oranges, Alex should refuse because he can produce the apples for less than 10, for 3. You see that? Good. Now, pause the video. Go back and try to understand what we just talked about. Okay. Let's move on to calculate the opportunity cost of producing oranges. Okay, we still have our numbers from before, right? So one nice trick the opportunity cost is you will invert the value and invert the unit. This here is the unit, right? Oranges lost per apple gain, that's the unit. And this 3 here is the value. So you take the inverse of it. Okay, maybe you don't believe me, and that's okay. But if you just want to work this from the top, well, let's try calculating the opportunity cost of producing oranges for Clara. We have 2 numbers for Clara, 200 each. And so here for Clara, in blue, we have 200 apples lost over 200 oranges gained. And so when we do the calculation, the value will be 1 and the unit will be apple lost per oranges gained. Pardon my handwriting, it's slowly just losing it. Okay, so now for Alex, remember the maximum number, I'm going to go up now. The maximum number of oranges that Alex could produce if he puts all of his factors of production towards that is 300 oranges, and the maximum number of apples is 100. So keeping those 2 numbers in mind, we are going to come here and 300 oranges gained, 100 apples lost. See that? So when you do the math, it's going to get us to 1/3 of an apple lost per oranges, or per orange gained. Sorry for squeezing things into the corner over there with all this space. Okay, let's answer some questions. Question 4a. Concerning these 2 numbers we have just calculated, these 2 opportunity cost values we have just calculated here. Who has comparative advantage in producing oranges? Who gives up less to produce an orange? It's Alex. Alex gives up only 1/3 of an apple. So Alex gives up less to produce, well, he has the lower opportunity cost. Okay, who should specialize in producing oranges? Alex should specialize in producing oranges. So again from the top, who has comparative advantage in producing oranges? It's Alex. Why? He gives up 1/3 of an apple, while Clara gives up 1 apple. See, so Alex has it. And who should specialize? Alex. What is the range of orange prices? It's between these two, right? So the range is a third to 1 apple. Now explain why this is the range. Let's start from here. Who is going to be selling oranges? It's Alex. Now Alex would love to sell his oranges for at least what it cost him to make it, right? So for a third of an apple or more. So he would like to sell that for a third of an apple or more. And so that explains why 1/3 is the lower bound on this range of prices. Now, can Alex sell his oranges for more than 1/3? Yeah, he can, but what's the upper bound? Could he sell his oranges for 8 apples? Sure, he can. But would Clara accept that? No. Clara wouldn't accept to buy an orange for 1 apple because Clara would not want to buy an orange, for more than 1 apple because she can make it for 1 apple. It costs her 1 apple to produce an orange. Okay, so that's why this is the max. Pause the video, go back and listen again to what I said. Now, we are curious whether there are any gains from this trade. And so we can look at production with these two individuals without any specialization and without any trade. What if they are producing and consuming their own apples and oranges and not trading at all, right? So that's what this is about. So we will take, what does this look like on a graph? Well, for Alex, I think I have been putting Clara in blue and Alex in black, right? So let's keep that here. So let's say this is Clara. Oranges up here, apples on the x-axis, and 200. Okay, so looking at just Clara, so this is Clara's column. Her production without specialization is 100 oranges and 100 apples. So right here. $100 oranges, 100 apples. So this is where Clara would be without any specialization and definitely without any trade, right on her PPF. What about Alex? Well, Alex, pardon me to draw both in blue. It's all right. I can use different colors later. Oranges, and that's 300, and that's 100. Looks like I'm doing this without my trusty ruler. That's fine. Oranges 150, so that's halfway here, and this is halfway, 150. Okay, great. So without any specialization, Clara can produce 100 oranges and 100 apples. Alex can produce 150 oranges and 50 apples. Great. Now, when we say specialize, right, we are asking Clara to completely focus on producing the good in which she has the lower opportunity cost. Clara will be specializing in apples. So in green, right, Clara, specializing in apples, she will move to this corner right from her production spot. She'll move to that corner to specialize, right? So specialize. Clara specializes in apples. Now, what about Alex? Well, Alex will be specializing in oranges, and so he's going to move from his production without specialization spot to that specialization spot on the corner. So here in green, Alex specializes in oranges. You see? So that's what it will look like graphically. The production without specialization, and then when they move on to specialize, that's what it will look like. Okay. Now to trade, we need a price. And up here, we calculated a range of prices. 1/3 to an apple for the orange prices, and 1 to 3 oranges for the apple prices. Okay, so I wrote out this price, which is falling in the range an apple for 2 oranges, right? An apple for 2 oranges. Okay, so here we have it. When price is set at 1 apple for 2 oranges, how is this gonna go? Well, I have to give you some more information, right? So suppose this is the additional information you need to complete the work. Suppose that Clara will sell 60 of her apples, right? So Clara is specializing in apples, producing 200, and she sells 60 apples to Alex. So 200 minus 60, she's left with 140 apples. All right, great. Now she sold those apples, those 60 apples to Alex. So 0 plus 60, that will equal 60, right? So with trade, Clara has 140 apples and Alex has 60. Where did Alex get these 60 apples? He purchased them from Clara. Okay. Now, Clara is selling 1 apple, well, at the price I quoted for you, right? 1 apple for 2 oranges, and she sold 60 apples. So if 2 oranges per 1 apple, then we're going to multiply that by the 60 apples she sold. And so we need to use this to calculate how many oranges. Some of you already know this, but let's work through it, right? So 2 oranges per apple can be written like this: per 1 apple times 60 apples. I want you to see why the answer is in oranges, right? Apple cancels out, and so you're left with 60 times 2. That's 120 oranges. Do you see how I got that? Yeah. The per is written as the division sign. Then this is the answer. So Clara will receive 120 oranges from Alex. So up here, that's the 300 minus 120, and this is plus 120, so we have 120 here for Clara. So this is great, right? This is great. We can see, by the way, this is equal to 180. Right, so Alex is left with 180 after selling those oranges to Clara at the price 1 apple for 2 oranges. Okay, so here we have it, trade. Can we visualize where trade sets Alex and Clara on the graph? Yes, we can. So for Alex, it's 180 oranges and 60 apples. So on the graph, 180, now let's use red to show that. 180 oranges and 60 apples for Alex. 180 is somewhere here and 60 apples is somewhere here. Now, do you notice how that is outside the PPF? Yeah. So in red, that is a trade. Trade sets Alex outside a previously unattainable point. What about Clara? Well, Clara here is 120 oranges and 140 apples. 120 oranges, so maybe that's about here, and 140 apples, that's about here. And so see, trade sets Clara outside her PPF, so that is a spot that was previously unattainable. So trade sets Clara in a previously unattainable point. This is a good thing. Remember, I told you that the height of the PPF, where the PPF ends, right? That's it. That's where the economy or the individual, that's the height their technology can take them, and that's the height their resources, their factors of production can take them. So if they would like to get to a previously unattainable point, they can use trade to do that. So this means that individuals with different technologies can trade and therefore benefit from that trade. Okay. All right. Are there any gains from this trade? I mean, graphically, you can see that there are gains from trade, right? So can we calculate that mathematically? Mathematically, the gains from trade are calculated as the trade numbers minus the production without specialization numbers. Now, to get this going quickly, I put those production without specialization numbers in there. Now we just need to add the trade numbers from the table just above. So here, Alex, 180. Apples for Alex, that's 60. Clara, 120 and 140. And so you can see that there's a plus 30 oranges and there's a plus 10 apples for Alex. For Clara, there's a plus 20 oranges, and for Clara, there's a plus 40 apples. See, so yeah, gains from trade all around for Alex and Clara. And I already showed that that was somewhere outside their PPF, and that's great. Those are out here. We drew them and visualized production without specialization, and trade on the graph, and that's what it looks like. Okay. Practice. Thank you.